Hello, Aspyre students. Today I will be reviewing over our electricity course so that anything you missed or forgot from our past lessons will be covered in these series of videos from our YouTube channel. So let's remind ourselves, what is electricity? Electricity is a type of energy that can build up in one place or flow from one place to another. It is the most important form of energy and power that we use. Some examples of these are batteries, which store chemical energy and convert it into electrical energy, or electricity, and electricity can be used to power devices such as light bulbs and laptops. So how is electricity generated? As you can see in this image, the energy stored in coal is stored as chemical potential energy. Burning this coal converts the chemical potential energy into thermal energy, or heat. Water is then pumped through pipes, which are then boiled into steam using the heat. Moving steam turns the turbine, which operates the generator, creating mechanical energy from thermal energy. The generator then produces electrical energy, or electricity, through a process called electromagnetic induction. All of these are the same bundles of energy, but just in different forms, which eventually lead to the creation or the transfer of energy into electricity. So the types of electricity are static and current electricity. Static electricity is when electricity gathers in one place as a result of an imbalance of charges. An example of this is rubbing your hair on a balloon. So when you rub the balloon on your hair is transferring the negatively charged particles, or electrons, onto the balloon, making your hair more positively charged and the balloon more negatively charged. This causes an imbalance of charges, which leads to static electricity, which is why when you rub your hair on a balloon, the hair can stand up in the air. Current electricity is when electricity moves from one place to another. So an example of this is turning on a light. When you turn on a light, there is a flow of electrons moving through an electrical conductor in an electrical circuit. We'll get more into circuits in the next video, but basically there is a flow of electrons which creates electricity, which powers on the light bulb. Another example of static electricity is lightning. And lightning is caused by a buildup of static electricity inside a storm cloud. And after we get more into protons and neutrons and how they play a role in electricity, I'll tell you more in depth about how lightning is formed. And another example of current electricity is charging your computer. It works similar with turning on a light. Like I've mentioned before, the current flows through the wire and the charger and eventually to the laptop. It's not an instant reaction, but rather a continuous flow of electrons, which is current electricity. So, you guys have already heard that static electricity is a result of an imbalance of electrical charges, and current electricity is the flow of electrons through a conductor in an electrical circuit. But what are electrons, and how do electrons become electricity? Electrons are negatively charged particles in atoms. So this is the basic structure of an atom. In an atom, there's a nucleus which contains neutrally charged particles, or neutrons, and positively charged particles, or protons. Orbiting around the nucleus are electrons, which are negatively charged particles. The electrons in the shell closest to the nucleus have a strong attraction to the protons. Sometimes the electrons in the atom's outermost shells do not have a strong attraction to the protons because of how far away they are from the nucleus, and so they can easily be pushed out of their orbits, causing them to shift from one atom to another. These shifting atoms are electricity. Electricity is the flow of electrons, and a force is needed to move electrons. But what force could this be? Electromagnetic force. This force attracts particles with opposite charges together and repels particles with the same charge apart. Electrons in atoms can act as our charge carrier because every electron carries a negative charge. If we can free an electron from an atom and force it to move, we can create electricity. Valence electrons are most likely to be transferred from one atom to another because, like I said before, because they're so far away from the nucleus, they're not as charged to the positively charged particles in the nucleus, which makes it much easier for the valence electrons to be removed from the atom as compared to electrons in the first shell. So if we can free an electron from an atom and force it to move, we can create electricity. Using enough electrostatic force on the valence electron, either pushing it with another negative charge or attracting it with a positive charge, we can eject the electron from orbit around the atom, creating a free electron using electromagnetic force. So here is a simplified model of an electric current. As you can see, electrons are moving from one atom to another, creating a current which causes electricity. Alright, so now that we have a deeper understanding of how electricity works from the subatomic level, let's go back to the static and current electricity examples. Rubbing the balloon against your hair causes electrons to be transferred to the balloon. This is because the balloon and your hair differ in how strongly they attract electrons. So, as I explained before, there's excess positive charge on the hair and excess negative charge on the balloon. And because opposite charges attract, there's an imbalance of positive and negative charges, which causes static electricity, which is why your hair stands up. However, a number of things can work against this. If the weather is humid, the excess charge on the balloon can leak away quickly. So this is more common in dry and cold weather. Now, with the lightning example, this is a bit more complicated. So as water molecules in the cloud are heated and cooled and they move up and down against each other, there is a separation of charge, which forms two poles within the cloud. One part becomes negatively charged and the other part becomes positively charged. Objects on the ground then become oppositely charged to the lower part of the cloud. This imbalance tries to resolve itself by passing current between the differently charged poles, which is a lightning bolt. Charged particles always flow in the direction where there are less particles of the same charge. This results in a lightning bolt. Sometimes the bolt will carry a positive charge and sometimes a negative charge.